Good evening, everybody. Back again with the I Came With Fire podcast. Tonight, we are here with Don Hoffman, who's a professor at UC Irvine. Don, you are the author of over 100 different types of paper. And the book we have here tonight, The Case Against Reality. I'll hold it up so everybody can see it. Go ahead and link that on our page as well when we post the episode. But thoroughly enjoyed reading this book, and also read one of your papers as well on the conscious agent theory.
Okay.
Extremely intriguing stuff. I feel like the concept of reality not being reality is a pretty hot ticket item right now with everybody. So it's a conversation I see and hear a lot.
Be a lot of fun to talk about it. Yeah, wherever you want to go with
absolutely
pursuing the non-reality of reality.
Okay, yeah. You're definitely the person to have that conversation with. So in your book, you make the claim essentially that our view on reality is not what reality actually is. It's an interpretation totally removed from what objective reality really is, because our perception throughout evolution is to maximize our survivability. And correct me and stop me when I'm not making sense, right? And that our perception is purely rooted in what we need to see essentially to survive. And if you could expand on that 30,000 foot view of your book, that'd be great.
That's right. So philosophers for thousands of years have speculated that perhaps our perceptions don't match reality to varying degrees. Plato has the very famous allegory of the cave, where he says that our perceptions are more like seeing the flickers of shadows of objects as flickers of the shadows of reality, not reality itself. But what's remarkable is that in the last few decades, our scientific theories have gotten precise enough that we can begin to ask, what do our best scientific theories say about our perceptions and the relationship to reality? So that's where I've been interested in going. I'm of course interested in what the philosophers say, but when our best scientific theories weigh in, I definitely want to hear what they have to say. And so one of those theories is evolution by natural selection, which is our I'm not saying evolution by natural selection is the final theory or the right theory, but it's the best theory that science has so far. And so as a scientist, it's my duty to look at what the best science says. And what's unique about evolutionary theory is that it has a model of our perceptual systems and how they evolved. And so you can ask, okay, does evolution say that our perceptual systems evolved to show us truths, at least some truths about objective reality, or maybe all the truth about objective reality? So that turns out to be a technical question that you can ask. And in Darwin's formulation, it wasn't mathematically precise enough. Darwin was not a mathematician. But evolutionary game theory, which came around in the 1970s, John Maynard Smith was the genius mathematician and biologist who put the mathematics to Darwin's theory and gave us evolutionary game theory. And it's then grown quite a bit. And so we have mathematical tools. And so we can ask a precise question of evolutionary theory. What is the probability that any sensory system of any organism has ever been shaped by natural selection to see any true features of objective reality, whatever objective reality might be?
Right.
Okay, so that's the technical question. I'll just state it more simply. I stated it precisely, but more simply, what's the probability that we were shaped to see the truth? Is the short question. And of course, some people might object and say, well, you can't use evolutionary theory to ask that question. It's first, how do you know what the truth is? And if you don't know what the truth is, how are you going to decide whether or not evolution shaped you to see the truth, right? So that's one objection that people will have. And the answer is, it turns out you don't need to know the truth is. You can say, suppose objective reality had this structure, like a mathematical structure, like a total order or a metric or topology or whatever. You can ask for each of those structures, what is the probability that evolution would shape us to see that? And one after another, you can go down the list. So, and the answer is the probability is zero. It's not just roughly zero. It's precisely zero in the limit as the number of states of the world gets large, and the possible states of the sensory system get large.
Right.
And so that's it's a stunning result. I actually didn't expect that result when I was starting this. I thought that
Right.
we would have, some exaggerations of the truth and cases that we missed and so forth. But to have it be precisely zero in case after case, total orders, metrics, topologies, whatever you pick, the probability is zero precisely in the limit that you're
Right.
going to, that any system would be shaped to see that structure. That surprised me. Now, another objection that philosophers will have to this approach is to say, you can't do this without being self-refuting, without getting yourself in a logical contradiction, right? So they'll say, look,
Definitely.
the argument is Darwin's theory of evolution has as fundamental concepts things like real organisms competing over real resources in space and time.
Right.
So now, if you're using evolutionary game theory to test Darwin's ideas and to decide whether or not we're seeing the truth, perceiving the truth, well, then either evolutionary mathematics that you have, the evolutionary game theory mathematics, is a faithful representation of Darwin's ideas, or it's not.
Right.
If it's not, then of course you couldn't use it to say anything about Darwin's theory. So you couldn't use it to ask this question about, do our perceptions perceive the truth? And if it does, if the mathematics of evolutionary game theory does faithfully represent Darwin's ideas, then it couldn't possibly contradict him. So either
Mm-hmm.
way, you can't possibly use evolutionary game theory to prove what you've done. So Hoffman, you've shot yourself in the foot logically. And it's not just one. There's several philosophers who've said that, some in journals. And so the reason why that's not a problem is their objection doesn't understand how scientific theories work and
Mm-hmm.
how the mathematics of scientific theories work. So I'll give you another example where it's a little bit clearer. So Einstein, in his theory of gravity and of
Mm-hmm.
space-time,
Right.
he had intuitions about light and also about falling elevators, right? And he had his he said this, his happiest idea was when he imagined himself in an elevator standing on a scale weighing himself. Then all of a sudden the cord is cut on the elevator and you're in free fall.
Mm-hmm.
And what would happen to your weight? And he realized that your
Weightless.
weight would be zero.
Mm-hmm.
And that was his big idea. He realized that the weight would be zero. And that was like in 1907. It took him until 1915 to turn that into mathematics. So he
It's
had the
incredible.
idea, but this is how science works. Even if you're a genius like Einstein, sometimes to go from the idea to a mathematical, rigorous statement of the idea takes a long time. So Einstein got his theory. And also Einstein had come up with some of the key ideas for quantum theory. I mean, he had his theory of the photoelectric effect was one of the first real quantum theories in 1905. So great. So that's Einstein's mathematics and his intuitions and so forth. Well, it turns out after he published his theory of general relativity, people used his mathematics, and we discovered that space-time, which is the fundamental idea that Einstein gave us, that space-time itself ceases to have any operational meaning at 10 to the minus 33 centimeters and 10 to the minus 43 seconds. In other words, when you use Einstein's mathematics, that Einstein himself said captures precisely the intuitions that he wanted to capture, his mathematics tells us that space-time is doomed. Space-time cannot be fundamental, and it falls apart precisely at 10 to the minus 33 centimeters and 10 to the minus 43 seconds, so-called Planck scale. So
Okay.
we don't. No one says no, you can't do that, Einstein. You're shooting yourself in the foot logically, right? Either your mathematics faithfully represents space-time, or it doesn't. And
Right.
if your mathematics if it doesn't properly treat space-time, then of course we couldn't use it to show that space-time is doomed. And if it does, it would never contradict space-time. Well, that last statement is the problem with the philosophical argument. And here's why. every scientific theory has a set of assumptions that it begins with. Like in Einstein's special relativity, it's the speed of light is universal for all observers, and all experiments give you the same result in inertial reference frames. But I'm sorry, not all the experiments, but all the laws of physics are the same in all inertial frames, right?
Okay.
But so what happens then is when we take those ideas and we make them mathematically precise, what we're doing is we're looking at both the power of those assumptions, the scope of those assumptions. What can they do for me? How much can I do? And in Einstein's case, they're incredible scope. But the mathematics also, and this is the key point, they tell you the limits of your assumptions.
Mhm.
No theory will ever be a theory of everything.
Right.
Every scientific theory makes certain assumptions, and those assumptions are where in some sense, where your explanation stops. You don't explain your assumptions, you assume them. And
Right.
so every theory is going to have its endogenous limits. And so a good mathematical representation will tell you not just the scope of your theory, but also the limits. And so what we've done then with evolutionary theory is to say, thank you, Darwin, for the incredible ideas, underlying evolution by natural selection, and thank you, John Maynard Smith, and the guys the scientists and mathematicians who turned Darwin's ideas into evolutionary game theory. That evolutionary game theory tells us both the scope and the limits of Darwin's ideas. And one of the surprising limits is our sensory systems are not shaped to show us the truth. Now, in some sense, that shouldn't be a surprise, right? If you ask an evolutionary biologist, what will sensory systems be shaped to do? They will say they'll be shaped to guide adaptive behavior. That's what Darwin's theory says. They're shaped to guide adaptive behavior,
Right.
period. It's an extra thing that just our intuitions, it's not Darwin's theory that's telling us, it's our intuitions that we feel like we better see the truth or we're in trouble, right?
Mm-hmm.
Or I don't want to even countenance the possibility that I don't see the truth. That would be,
Right.
that's sort of when people really take that seriously for the first time, it's scary.
Mm-hmm.
What do you mean I don't see the truth? That's so we would rather not even go there. And I understand that I'm like everybody else. I would, it's sort of unsettling to think that we don't see the truth. But Darwin's theory says very, very clearly, our sensory systems are shaped to guide adaptive behavior, period, not to show the truth. And the intuition, I think, that really helps to see how that works is again like playing a game, a video game on your computer or virtual reality game, right?
Right.
If you're like playing a game like of Grand Theft Auto or something like that, um, the reality that you're interacting with, I mean, what you see is like a red Ferrari. You see your steering wheel, you see your dashboard, you see a green Mustang you're racing or whatever it might be.
Right.
But the reality that you're interacting with in this metaphor is not a red Mustang or a green Ferrari, whatever it might be. It's just some supercomputer somewhere, right? That's what. So, and what you're really doing in this metaphor is you're toggling millions of bits per second. You're just toggling
Right.
values of bits in a precise order. The sequence of bits has to be exactly right for you to play the game. So now, one way to try to play the game is to get in there and actually get into the computer itself and try to probe and by hand do all the bits as fast as you can. Good luck.
Yeah.
You,
No.
you will lose, right?
Absolutely.
If you see the truth, you won't win the game. So what we have is a little user interface with a steering wheel and a dashboard and a gas pedal, and that lets you play the game.
Right.
Say Grand Theft Auto game successfully, whereas knowing the truth will be hamstring you. It'll keep you from actually competing. And so that's what evolution is done. It gave us a headset. It gave us a VR headset to play the
Right.
game of life, and you don't need to know what's behind the headset at all to play the
Mm-hmm.
game. In fact, it would be a liability to have to deal with the reality behind the headset, just like it would be a liability to have to toggle the voltages in a supercomputer to play the game of Grand Theft Auto. So that's the intuition about why we don't see the truth, and that's just evolution by natural selection.
Hmm.
You, someone might say, well, okay, right, saying that space and time are not fundamental and objects in space and time is not fundamental, that's really the bailiwick of physics. And and that's not, so surely the physicists will put you in your place.
Hmm.
And what's remarkable is that the physicists themselves are, and it's a certain subset of physicists, I just say, they're the high energy theoretical physicists. So these are the physicists who are dealing with the really highest energies. So they're pushing physics to its limit, to the smallest scales, and looking at what's happening at the smallest scales, and thinking about that. And they're the ones that realize, oh, at the Planck scale, it falls apart. And
Right.
therefore, we need a brand new framework. We can't just fix space time. We can't tinker with it. We need something brand new and deeper. And they're finding, just in the last 10 years, so this is fairly new, but in the last 10 years, they're finding structures entirely outside of space-time. And I really mean that. They're not like structures curled up inside space-time.
Right.
And it's hard for people to think about how, what do you mean outside of space-time? Isn't space-time everything there is?
Right.
And the answer is no, space-time is just your headset. So think about space-time is just your headset, and just imagine now of something outside the headset. And that's outside of space-time. So space-time has a real grip on our imagination, but it doesn't take much effort to, if you think about it with the metaphor of a headset, okay, so space-time is just my headset. I'm creating it on the fly. Now imagine something that's entirely outside my headset. And that's where the physicists are. And they're finding mathematical structures. So our best theories, evolution by natural selection, and then high energy theoretical particle physics, like quantum field theory together with Einstein's theory of gravity, they're all saying the same thing. Space-time and objects inside space-time are not fundamental reality.
Hmm.
Something deeper is more fundamental.
Well,
And the
two
race is on
things.
to find it. What
Right.
is it?
Right. Next Nobel Prize for sure.
Yeah.
Uh, Two things with that. Human beings are very good at cognitive bias, cognitive dissonance, right? So we're very good at looking even at objective truth and turning it into subjective truth for our own purposes, right? So it's not, to me, a large leap to say that our brains and the way we're interpreting our reality is kind of the same way. It's that sort of dissonance that is there, not on purpose. Well, on purpose, but not in a intentional way, I guess, right? So because you can have too little or too much of something, and neither is optimal for survival. So we are viewing it just the way it's meant to be. And these topics are very existential, obviously. That's one of the things I find so intriguing about this conversation is it leaves room for the metaphysical, I feel like. And go back
Yeah.
to your Plato's allegory of the cave.
Right.
And then, these, when you talk about like, Newtonian physics, Einstein's theories, these are all just stepping stones. Like you said, there's assumption inside of them moving towards a broader, deeper understanding of like our own universe. But what does, this do, understanding that conceptually our perception of the universe is not real? What does that do to those sort of theories? Does it, invalidate them? Does it, in a way, justify them as just the baby steps towards understanding? What does that do?
Well, that's a great question because it really gets to the heart of what is science doing here. I mean,
Hmm.
did did we screw up? Is this a big
No.
screw up, or is this necessarily the way science works? And I think it's the
Right.
latter. That as I
Agreed.
mentioned earlier, every scientific theory makes assumptions,
Right.
and those are the miracles of the theory. Those are the
Absolutely.
things that we don't explain with the theory; we assume them.
Hmm.
And that's the nature of scientific explanation. You can't get a theory without assumptions. So
Right.
every scientific theory will only be a theory of everything except my assumptions,
Right.
not a theory of everything. And so we're that leads to infinite job security for science in principle. right? Because we'll always be looking for deeper and deeper foundations for our
Hmm.
theories. So it's not a mess up on the part of science that it has been using space time or space and time, and more recently space time, as the foundational concept for centuries. So space and time for centuries, space time since 1905,
Right.
since and so those have been fantastic foundational concepts, and we've done a lot with them. But now it's time to go outside of space time. But what's interesting is we don't just say, "Oh well, space time, what a bummer. It was a bad trip, and we wasted our time." Absolutely not. It was not a waste of time. It was
Right.
exceedingly valuable. Effectively, what we were doing is studying our headset. We didn't
Hmm.
know it, but we were studying the the structure and the function of our headset. We thought we
Yeah.
were studying objective reality. And so it's really important to understand our headset. And we
Hmm.
learned all these incredible tools about precise mathematical models and experimental tests. So, I mean, humanity really pulled itself up by the bootstraps in the last 5 centuries with the scientific method. It's really
Sure.
quite incredible. And moreover, that's not the only job of our current theories of space-time and physics. As the scientists begin to move outside of space-time and find structures like it, there are structures like the decorated permutations and amplitude-hedra and cosmological polytopes, and there are these structures that they're finding, right? So it's not just a hand wave. They're real structures that they were finding that can actually predict, like, for example, scattering of particles in
Hmm.
collider experiments
Right.
at CERN and so forth. So what
It's
the
incredible.
current physical theories of space and time are going to do for us is, as we get these new theories outside of space-time, we have to show that when they project into space-time, they give us the physics of space-time that we already know and love. If they can't give us back the physics we already know and love of space-time, then our other theories are wrong. So
Hmm.
so so our theories of space-time can't tell us what's beyond space-time. That we actually have to take a creative leap. That's the fun of science. And that's why the younger generation is usually the generation that takes the leap, right? Right. The
Sure.
old fuddy duds had their stuff. Now it's time for us to make our creative leap. And so this is a fun time for them. They're jumping outside of space time and finding wonderful stuff. The catch is when you project it back into space time can give you a thumbs down or a thumbs up. If
Hmm.
you can't predict the scattering amplitudes for particles at colliders, for example, then you're wrong. You're not even wrong. You're not even interesting, right? So the theories in space time that we have and know and love, they may prompt our ideas, but they really can't tell us what is beyond space time. So they help give us intuitions and so forth, but we really have to take the creative leap. What they can do is tell us no if we're wrong, and if they don't say you're wrong, it doesn't mean you're right. It just means that they can't tell you that you're wrong.
Find another way to make a light bulb.
That's right. So that's the way science works, and again, that's why the philosophical objections about using the mathematics for scientific theory to show the limits of the theory is just wrongheaded. It completely misunderstands how science really works.
Right. So let me ask you this. We've evolved to this point where our perceptions are the way they are. Does that mean that we would have to be further evolved to understand things outside of space time as we interpret it now? Or do we have
Well,
the tools?
it depends on what theory you use. So
Okay.
if you only have Darwin's theory,
Hmm.
then the answer might be yes. I mean, you from Darwin's theory,
Hmm.
but we realize that Darwin's theory is just a theory inside our headset,
Hmm.
right? It's not. It's the best theory we have, and it's a beautiful theory of biological evolution inside the space-time headset. But as soon as we get outside of the headset, right, we the fundamental tenets of Darwinian evolution may no longer be relevant at all.
Hmm.
I mean, for example, the Darwinian evolution has limited resources and competition for limited resources. And one of the most fundamental limited resources, perhaps the most fundamental, is time.
Mhm.
right? If you don't get food in time, you die. If you don't
Mhm.
get your oxygen in time, you die. If you don't mate in time, you don't pass on your.
No
So
reproduction.
time is like the fund. So there's limited resources, but time is really. And so
The
and,
currency.
and there's an arrow of time, and that's in our headset. We
Mhm.
have this arrow of time, but it's possible to write models of dynamics outside of space time
Mhm.
where there's no arrow of time, where the dynamics is sort of like a Markovian dynamics that's stationary. But what you find is that so you can have a dynamics in which time is not a limited resource outside of space time.
Right.
The dynamics doesn't have a time limited resource, but when you project it by conditional probability, so you take this dynamics outside of space time and project it by conditional probability into space time, then you will, or not even into space time, just anything, any projection, you will get an arrow of time.
Mhm.
And the arrow of time is not an insight about the original dynamics. It's entirely an artifact of the projection. It's
Mhm.
actually not informative about the reality. It's only misinformation due to the loss of in the projection.
Understood.
So, so we could imagine that there is a dynamics of entities outside of space-time in which there are no limited resources, in which there is no competition, and so that opens up the possibility that all of our concepts about levels of consciousness and evolution of consciousness are not an insight at all. That's entirely an artifact of our headset perspective, and
Mm.
is not a deep insight. And that's one of the things that that's one of the things that's scary, but also really exciting about this kind of science. It's
Mhm.
scary to think that I could be so fundamentally wrong in things I've believed all my life. I mean, almost everything I've believed all my life could be deeply and fundamentally wrong.
This is exactly what I wanted to ask you. When reading your book, a couple of the first thoughts I had is, how did he grow up? Did he grow up in a religious home? Because some of these concepts I know to people in my family would be totally outside what I should be thinking, right? And then obviously you're going through your life and you become a professor and you're learning all this stuff and you're developing your ideas and theories. Has there ever been a point where this has contradicted with your own personal belief systems and interacted with it, and what has that felt like and what has that done?
Um, all the it contradicts my deeply held emotions
Yeah. Okay.
from head to toe. I mean,
Hmm.
it completely. The first time I got a glimpse that this might be where the math was leading me, I had to
Hmm.
sit down. It was such a stunning experience. I had to just sit down, and even though I talk about it and I've done all this math, every instinct inside me rebels. I mean, it's scary to think that I don't see the truth. Um, and it's just natural to think that I see a rock, that's because there is a rock. Of course the moon is there, and the moon has been there for 4 billion or 5 billion years, and the moon will be there even if I don't. I mean, all these natural intuitions that we have, and then my very self-conception then is on the line as well,
Hmm.
right? If objects in space-time are not the reality, they're just a virtual reality, then what I'm seeing here, I look at my hand and so forth, I'm not seeing the truth. I'm seeing my avatar. This is not the real me. This is just my avatar. It's like, again, in the Grand Theft Auto VR kind of thing. If I
Hmm.
see my hands on the steering wheel in the Grand Theft Auto, well, those aren't really my hands.
Right.
That's, I mean, those are just symbols in my VR. Well, I'm saying that's what my entire body is. And that's, for
Hmm.
example, my brain and my neurons. Those things don't even exist unless they're rendered by looking. Like
Yeah.
in virtual reality, right? If you're playing Grand Theft Auto and you see a red Ferrari to your right, well, there is no red Ferrari in the supercomputer. Where is that red Ferrari? Well, it's only there when you look, when you render it, when you actually see it.
Hmm.
As soon as you look away, there is no red Ferrari anywhere. Now
Right.
you might say, well, my friend over in China who's playing, multiplayer game with me, he sees the red Ferrari. Well, that's because he's rendering his red Ferrari, and his red Ferrari is not the same one as my red Ferrari.
Right.
And so but when it gets personal, your question is about the personal impact.
Hmm.
When I realize I'm rendering my body, that
That's
doesn't get any
huge.
more personal than that. And
Right.
trying to grok, what am I? What is it that I really? So most of us think, well, I'll tell you what I am. I'm Don Hoffman. I weigh 165 pounds. I was born here and here. And when my body dies, that'll be it. Well, that's one story, but that story doesn't sit with our best line. That 165-pound thing is just an avatar, and it
Right.
doesn't even exist unless it's rendered. It's not even there. So the question then becomes really profound.
Hmm.
What am I? And I mean, normally
It's
you want to say,
flirting with
well,
the religious
expletive
line.
am I?
Right. Yeah. Right.
I mean, so it becomes very, very personal, and so lots of people in spiritual traditions are interested in this kind of research because it does. Here's where science is now, forcing an issue
Hmm.
of asking, I am whatever it is that's doing the science and asking these questions,
Hmm.
and whatever I am that's doing that has coming to the conclusion that this body is something that the whatever I am is rendering on the fly. So what am I that's doing the rendering on the fly of the moon, the sun, the earth, and my body and my hands? And that's truly profound. And so many spiritual traditions will say, well, welcome to the club. We've been here for thousands of years. We've been
Hmm.
asking that question. And the scientists are sort of latecomers. And yeah, we are. And it's a shocking kind of party to join for all of us. It's, I think, even people who are in spiritual traditions and have meditated
Oh
for a
yeah.
long time is still like, holy smoke. I mean, it takes a long time to readjust your self-image.
I,
But
I
readjust it to what?
right. I think it's really interesting. A lot of religious concepts have the concept of something obviously outside the self, and that this is just a vessel. That there, the concept of the soul, and some of the more Eastern traditions of like unknowledge, unlearning what our perceptions are, and all this. And I've sort of long held
Yes.
that belief that science and religion are trying to answer the same question, which is obviously it's that broad question of why, how are we here, why are we here, all of that, right? Um, I've
Yep.
been wondering, like, have you ever worked with somebody or had a conversation with somebody with the objective of learning and deepening your understanding of your own postulations from a religious standpoint, or trying to incorporate conceptually some of those religious standpoints?
Yes, I've had lots of conversations with spiritual teachers of various kinds, so
Hmm.
and from various traditions. So with a Jewish rabbi,
Hmm.
um, uh, Joseph Dweck,
Hmm.
with the Dalai Lama, um, with Rupert Spira, who's a wonderful spiritual teacher. Um, Deepak Chopra is actually a good friend,
Yeah.
and we've
Oh
had a
wow.
number of conversations.
Wow.
And also people who are uh, mystical Islam. Um,
Hmm.
we had conversations, so I'm
It's
very
interesting.
interested. And my attitude is I think that they have a big piece of the puzzle,
Hmm.
especially the mystical traditions. Also, by the way, in mystical Christianity, like I'm very interested in like what the Benedictine monks have to say, Thomas
Hmm.
Keating, and so forth.
Hmm.
And also spiritual teachers like Eckhart Tolle. I
Hmm.
think they're truly profound, and they're on to something very, very deep.
Right.
Um, where science and science hasn't been in this field very much. Or
Right.
we've been in space time, and
Right.
this is something beyond space time.
It is.
But my best guess on what's going to happen going forward is we're going to find that many of the ideas in these spiritual traditions are very, very valuable.
Hmm.
Some are nonsense.
Sure.
And what science is going to bring to the table is the precise mathematical language
Hmm.
and the tools of experiments and critical tests.
Hmm.
And I think that there's going to be this wonderful rapprochement and actual synergy between science and spirituality, where the wonderful tools of science that we've sharpened by understanding our headset. We thought we were understanding reality, but we were understanding our headset.
Right.
But now we can use those tools to go beyond the headset, and where the spiritual traditions have said, I think, true and useful things, but they would tell you that the real good spiritual teachers would say that our language is just pointers, right?
Hmm.
It's not, don't mistake what we say for the truth. Um, Use it as a pointer and then drop the pointer,
Hmm.
right? Like the Tao Te Ching says, the Tao that can be spoken is not the true Tao. It starts off by saying, don't take the words too literally.
Right.
Try to see through the words into yourself,
Hmm.
and don't get hung up on dogmas that will come out from taking the words too
Right.
literally. And so and that I, the nice thing about the mathematics in science is it says the same thing. Our scientific theories are not true, but
Hmm.
they're precise. And they tell us the scope. Because of that precision, we understand the scope and the limits, as we said at the very start, the limits of our theories. And that is the antidote to dogmatism. When your own theory tells you precisely this is where I stop,
Hmm.
then there aren't going to be, holy wars over misreadings of various kinds of scriptures and so forth, because
Right.
the mathematical theories themselves will tell you, hey, take us seriously this far, and then don't take us seriously beyond that.
Hmm.
We stop, and so and I think the spiritual traditions would all agree that ultimately, yes, no pointer is it.
Hmm.
Every pointer should be taken with a grain of salt, but as helpful. And as soon as it's not helpful, drop the pointer and look for other pointers.
Hmm.
So, yeah.
So, religion, spirituality, whatever you want to call it, it holds a lot of truth for a lot of people, and it gives a lot of comfort, gives a lot of guidance. People use it as a way to understand who they are and their family and all of that. And would you say then that, like we said, that religion and science sort of try to answer the same questions in some ways, that maybe religion and spirituality, these are just primitive attempts at understanding that metaphysical side to what reality, objective reality is?
That's a great question, and I should say up front that scientists um, have addressed that question
Hmm.
and disagreed. So there are some scientists who will say, look, there are two separate arenas. There's the arena of science and there's the arena of spirituality, and never the two shall meet. And science does what it does, and spirituality does what it does.
Right.
And then there are others that say, no, spiritual traditions are making truth claims.
Hmm.
And as soon as you make truth claims, then science is interested. And I'm more of the latter type. I think that both science and spirituality are trying to make claims about
Hmm.
the nature of reality.
Hmm.
Um, and they're truth claims, but as I've said, they're not the ultimate truth. They're just, here's maybe what we should say, instead of a truth claim, it's a useful perspective on the truth, right?
Right.
This is a useful perspective on the truth, but it's not the final word. So I think that my take is that um, science and spirituality are both a quest for the same thing, basically to understand, who am I? Who
Right.
are we?
Right.
What's going on here? What's this all about?
Hmm.
And what does it mean to live a worthwhile life, for example? I mean, you get
Yeah.
80 years if you're lucky, 90 years if you're really lucky. Um, what what is it about, and why are we here? And the answer in science and spirituality have been very, very different until recently, right? So within the physicalist framework of science, it's been, look, space-time is fundamental. You are your body,
Hmm.
and your consciousness, and all your emotions, your hopes, your dreams, and aspirations, all that conscious stuff that's so important to you, is entirely a product of your brain, or your
Hmm.
embodied brain,
Hmm.
or your embodied brain in an environment, depending on who you're talking to. And so of course, when your body dies and your brain decays, all those hopes, dreams, aspirations dissolve
Hmm.
utterly, completely. There's nothing left. That's one framework. Whereas the spiritual traditions have said, no, 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 no. There's something beyond the space time and
Hmm.
the physical, but they haven't had the tools to do anything about it. There's nothing. There's no, like experiments that are. I mean, there are experiments and so forth, but
Right.
nothing that
Nothing
reaches the
conclusive.
level where the majority of scientists will take it quite seriously.
Right.
That's been the state of play until recently, but now I think with science and scientists saying space-time is doomed, and now asking, okay, well, what is outside of space-time? And when we start having dynamical entities, when we have
Hmm.
dynamics of entities outside of space-time, the question is going to arise. What are these entities outside of space-time that are having dynamics? And they're not confined to space-time anymore. Well, that sounds like what spiritual traditions have been saying informally
Hmm.
for a long time. And
Yes.
now science may be forced to say it formally and take it quite seriously. So I think that there will be a lot of useful collaboration, talking back and forth between science and spirituality. They're very, very different languages, and so there's going to need to be a lot of compassion, a lot of persistence, and so forth to
Right.
bridge the gap. And of course, certain individuals will bridge it within themselves. There are some people who are first-rate scientists and maybe spiritual, quite spiritual as well. So,
Hmm.
I see going forward the rift between science and spirituality may mend,
Hmm.
and it will be useful. I think beneficial for all of mankind. Um, but I think
Agreed.
everybody on both sides will have to give up
Something.
things that they dearly cling to,
It's true.
including your answer to the question, "Who am I?"
Hmm.
Which is one of the deepest and most important things. So we're in for an exciting ride here, and
I hope I live to
we have to
see
be
it.
open to being wrong and to being surprised.
Right. Going back a little bit to what you said, the word entity invokes a lot of different thoughts when you say that, right? So are you saying that science has maybe has or begun to discover entities outside of space-time, meaning something that has some sort of consciousness, or am I misunderstanding?
Well, entities right now only mean mathematical structures.
Understood.
So the physicists, for example, who have discovered things like the amplituhedron and decorated permutations, I think none of them would say that they have anything to do with consciousness whatsoever, right?
Okay.
They would just say these are structures outside of space time that remarkably allow us to actually compute the probabilities of particle interactions at colliders inside space
Hmm.
time and do it much faster and more cleanly with more insight than if we did it in space time. So when you
Hmm.
go out, by the way, when you go outside of space time, the math becomes simpler and the computations become simpler and you see new
Oh,
symmetries. So
okay.
you're getting another hint. Space time is really um, just a crude headset. And when you let go of the headset, you see the deeper structures and the math becomes much more beautiful and you see symmetries and so forth.
Mhm.
So that's really quite intriguing. But none of them, I haven't seen any who who are these high energy theoretical physicists who would want to at this point say that their mathematical structures
Hmm.
are conscious entities in any sense.
Okay.
However, they're not doing dynamics right now, right? So
Hmm.
they just have these static structures. Ultimately, if physicists find that there's some kind of dynamical system outside of space-time, the question is going to come up now. Okay, what are these entities? Why are they doing anything? And
Hmm.
what's going on here? And the idea that maybe these entities are conscious entities will certainly be something that will have to be at least considered. If
Hmm.
that maybe they want to discard it, but it will be something that you'll maybe want to consider. Now, there are things like people might say, well, it's just automata. So there are these automata outside of space-time,
Hmm.
like little Turing machines or something like that are interacting. And that might be one way that you go. You just and there's no consciousness out there.
Hmm.
But there'll be automata outside of space-time. These are not little creatures inside space-time. They're utterly outside of space-time. So
Some
already
crazy
that's
stuff.
that's weird enough.
Yes. No, that is. So speaking of math, how earlier to be in the conversation, obviously, anyone who's read your book, you say the probability is zero, right? Of us understanding objective reality the way it is. How do you mathematically come to the determination that it is zero?
Right. So without going into the weeds too much, just at top
Sure.
level,
Sure.
um, the idea is that in evolutionary theory, there are these things called fitness payoff functions.
Mhm.
So if I eat a steak and I'm a human being, that has positive fitness. If I eat
Mhm.
some vegetables, maybe even better fitness. But if I
Sure.
eat uh, poison ivy, it's
Right.
going to be really bad for my fitness, right?
Right.
So you can imagine saying, okay, if I take this action, eat a steak, I
Right.
could get good points. Maybe I get 100 points. If I get poison ivy, maybe it's minus 100 points, right?
Right.
That's bad for me. And
Sure.
maybe if I have vegetables, maybe it's plus 200 points. In other words, you put a rating scale, and then also, if I mate with a human being, well, if I try to mate with a tree, well, that's like minus 100 points. It's not going to do anything for you, right? That's not
Right.
so for all these activities, you can talk about what is the payoff for those activities, and those are the fitness payoff functions. And
Mhm.
so the payoffs are going to depend on, if you think about it, okay, well, I mean, what's a good payoff for a human being is different for what's a good payoff for a donkey, right?
Sure.
Right. For example, human beings mating with human beings is a good deal, but
Yeah.
not mating with donkeys, and vice versa for the donkeys. So the fitness payoffs depend on the organism, like humans versus donkeys, the state of the organism, like you're hungry or thirsty or whatever, and the action.
Mhm.
Feeding, fighting, fleeing, or mating. The the
Mhm.
the, the famous 4 F's. So it depends on the state of the world, the organism, its state, and the action. So they're
Okay.
complicated functions. Now you can ask a technical question. Suppose, so this function starts with the state of the world and it gives you a number, like from 0 to 100. 0 means you're screwed.
Right.
100 means you're wonderful, right? That's
Wonderful.
a good payoff. So these are the fitness payoffs are the things that drive evolution.
Mhm.
They're the coin of the realm. So the question then is, it's a function from the state of the world to 0 through 100. So suppose I want to know, will this fitness payoff function allow me to see the structure of the state of the world, the truth, right?
Mhm.
So suppose the world has something like what we call a total order, like 1 is less than 2 is less than 3, and each one, that's a total order. Or it could be a metric. A is this far from B, B is this far from C. That's sort of a distance. So in each case you can ask, what is the probability if I look at all the possible fitness payoff functions? And there are lots of fitness payoff functions. And evolutionary theory doesn't tell you which payoff functions to choose are the real ones, right?
Right.
They say a fitness payoff function starts with the states of the world, the organism is state in its action, and it gives you a number.
Mhm.
But there's nothing in evolutionary theory which puts a limit on the relevant fitness payoff function. So any possible payoff function has to be considered in current evolutionary theory a relevant payoff function. So we can look at the space of all possible fitness payoff function. We can say, just suppose a simple world has just 100 states in the world. It's not the
Mhm.
real world, but okay. And we can look at then, and we're going to look at only payoff values from 0 to 100. So
Mhm.
we can actually then write down all the possible fitness payoff. That's a toy model, but we can look at it, right?
Yes.
And we can say how many of those fitness payoffs would preserve, say, a total order on the world,
Mhm.
like 0, 1, 2, 3, up to 100. That total order. Well, that's a mathematical problem you can solve, and the answer is 0. 0%. There are some, but when you look at the number that actually preserve the total order divided by the total number of fitness payoff functions, what you find is it's very, very small for 100. And as the number of states in the world goes from 100 to 1,000 to a million to a billion and to infinity,
Mhm.
the fraction of payoff functions that actually have information about the structure of the world goes precisely to 0. And
Mhm.
this happens over and over again for any structure that you want to look at, metric, measure, measurable space structure, whatever you want, it goes to 0. So that's a little in the weeds, but
No, no, no. You
that's
can
how we
venture
do it.
off into the weeds a little bit for sure. You very eloquently put that. I appreciate that. Um, so these fitness payoffs, obviously, there is biological markers in human beings for determining fitness, right? So, how do those blend into some of those concepts in your book where you talk about like beauty? right? And
Right.
understanding, how somebody is determining somebody's maximum potential for reproduction or whatever, which obviously is the end goal, right, of relationships that way. How do those blend, those fitness payoffs, and like you said, the concepts of beauty and biological markers?
Right. So evolutionary theory, which is our best theory inside space-time about
Hmm.
our bodies and the evolution of our bodies and our sensory systems, um, again, is not the final word, but it's the best
Hmm.
word we've got. And it gives us incredible tools
Right.
for understanding, for example, attractiveness. What
Right.
we've, as you raised that issue of attractiveness. And so, from an evolutionary point of view, what is um, sexual attractiveness? Well, from an evolutionary point of view, what's really going on is when you look at a person, and in that first glance, the first 500 milliseconds, half a second, what your visual system and your sensory systems more generally are doing is they're hoovering up dozens and dozens of visual, auditory, um, olfactory cues
Sure.
from that person, and you're doing one of the most complicated computations that you ever do in your entire life. You're looking at dozens and dozens of cues, and you're computing one thing. What is the probability that the person in front of me could successfully have and raise kids? You're not doing that consciously. You
No.
just get a hit like this person is cute or not, or
Yeah.
they're hot or not.
It's just
Um,
happening.
it's automatic. But what's so that feeling of attractiveness is a really sophisticated computation. And so what we've been able to do is to dig into that computation. What are the cues and what precise values of those cues make you look more attractive or less? And so one cue that I and some of my graduate students, Darren Peshek, and others, Nagar Samak Najad, um, worked on was the eye and something called the limbal ring of the eye. So if you look at an eye, there's the white of the eye, and then there's the dark iris. And if the iris is not too dark, so if it's a light brown or a blue or a gray or something like that, then in many cases you can see a ring right where the white meets the dark. And that ring uh, can only be seen if your eye is clear, right? If you have a bad eye, if it's bad, you can't see the ring. And it turns out that in infants, the ring is a little bit thicker proportionally, and it gets statistically thinner as you get older.
Hmm.
So a thick and clear ring is a statistical indicator, not a perfect indicator, but a statistical indicator of youth and health. And that's what you're really looking for in your evaluations of sexual attractiveness. The ratings of males for females, and by the way, right now I'm talking heterosexual. There's not a lot that is known about these same cues in homosexual
Interesting.
attractiveness. So I'm going to, for now, just have to say don't know.
Sure.
Interesting, but don't know. My
Yeah.
guess is that they're going to pick up on many of the same cues. My guess, but I don't have the data, so I have
That's
to be
really
very
interesting.
clear. But my guess is that um, heterosexual and homosexual, the cue that I'm talking about is going to be the same. That it will
Okay.
have the same effect. It will increase attractiveness
Mm.
in both cases. So what we did was to test this. We got subjects into a room, an experiment. We had them sit in front of a computer, and we would flash the same face but two pictures of the same face that
Hmm.
looked identical. But in one of them, we had just altered the limbal ring, made it a little bit thicker and a little bit more pronounced.
Mm.
And we just asked the person. We said, we're going to show you a bunch of pairs of faces. On each trial, you'll see a pair of faces, and pick the one that's most attractive. So
Right.
we'd start the subjects in the experiment, and after a couple of trials, they go, "Wait, the faces are the same. I mean, is this a trick? I mean, I don't see any difference." We say, "Yeah, they just humorous. Just go with your gut, right?"
Choose.
And so they go, "Okay, well, I'm going to." So, and what happened was, well above chance, they would pick the face with the more pronounced limbal ring,
Wow.
and so So, and they didn't even know that they were seeing it. So this is the key thing. You don't even know consciously what it is you're picking up. All you know, but you are picking it up. There's some algorithm inside your head that's looking for that. It evaluates that limbal ring and it puts it into the computation of thumbs up or thumbs down on the
Hmm.
attractiveness. So, and there are dozens of cues like that. And so
Hmm.
I've done a lot of consulting for companies where I help them with their products and their advertising, because
Oh, wow.
once you understand how this works, you can grab people's attention and make things look attractive.
Yeah. Definitely think that lends more credence to what you're saying about how about survivability and us and our perception, because that's the whole point of reproduction is survivability. So of course biologically you evolve to, and not everybody does, this is obviously there's certain biological markers that people find more attractive than others, right? So not everybody has those, but I think that's very interesting because it is, they play right into each other, they're espoused that way. um, that was a concept in your book I found really interesting, because it's when you're taking these super like scientific looks at things, and I'm not a scientist, but I think that the biological aspect of it and just attractiveness of reproduction, I feel like would get lost. You know what I mean? And you did a really good job outlining that in your book, where I can understand, and other people
And
do.
then for a lot of people, that's fun stuff, right?
Yeah,
How to be attractive. I actually give you pointers of what you can do to look attractive, including
yeah,
in your genes. What you need to do to look attractive in your genes and so
yeah.
forth.
You got a pretty good picture in the book there. The people have to buy it to find out. But yeah,
That's right.
yep,
Yeah, just a little bit of change in your genes can make you look a whole lot hotter. So,
right. Exactly. So, was there a point in your career, right, where you can remember thinking, "This is what I want to study, and this is where I want to go with this," or has this always sort of since you began your academic, life, something that's been in the back of your mind?
no, it's been even since my teenage years. I've been interested in the question of who are we?
Hmm.
Am I just a machine? That was the way I thought about it as a teenager. Am I a machine, or am I something more like the spiritual traditions say? Am I something that's not just a machine? And
Hmm.
I decided that the best way to do that, and not just I didn't want to take things on faith. I'm hard nosed. I want to actually dive in and understand it as best as we possibly can.
Hmm.
So I figured the best way to do that would be to jump into the field of artificial intelligence, which at the time was a new field, because that's going to tell me how far can the machine metaphor go.
Hmm.
Can If artificial intelligences can do everything humans do and more, then maybe we're just machines.
Hmm.
But if there's some limit, then I want to know what that limit is. So I wanted to understand both human neuroscience and human cognitive neuroscience and artificial intelligence. So I ended up going to UCLA, but for my upper division undergrad, and then to MIT in the
Hmm.
artificial intelligence laboratory at MIT, and with now the brain and cognitive science department. Um, both camps there. So I did the artificial intelligence stuff and I did the cognitive neuroscience to really understand. Okay, is there something special about humans, or could AIs do it all? And I started there in 1979, and it's
Wow.
it's still, AI went through some low points in the intervening decades, but its resurgence is real right now, and
Hmm.
there's a lot of questions. The questions that got me going in the late 70s. Are we just artificial intelligences or not? My take is that we're we aren't even entities in space time, right? My body is just an avatar in a headset. The space time is not the so that our
Hmm.
best science is telling us whatever we are, um, we're not machines inside space time. Now it doesn't rule out that we're machines outside of space time, but we're not
Hmm.
machines inside space time.
Right.
And now the other thing that's quite interesting is that I have a lot of brilliant colleagues and friends who are studying consciousness from cognitive neuroscience and AI points of view, and trying to, for example, show how consciousness could be booted up from neural activity or orchestrated collapse of quantum states of neuronal microtubules and so forth, or integrated information. And these are, brilliant friends and colleagues. They're absolutely brilliant. But what's remarkable is there's not a single specific conscious experience.
Hmm.
Taste of chocolate, smell of garlic, feeling of
Right.
a headache. There's not a single specific conscious experience that they can explain with any of the theories. Not one.
Mm.
They're batting zero on specific conscious experiences. And no one really has a clue. The closest they've gotten is integrated information theory has tried to come up with the feeling of spatial, just space. But the question I would put to them is, well, visual space, auditory space, somatosensory, those are very, very different feelings of space. Which one is yours? And what makes yours auditory or somatosensory or visual space? And why is it in principle that kind of space and not the other?
Mm.
There's nothing on the table.
Mm.
So
Okay.
so that doesn't mean that they won't, but my take on it is the failure is principled. These are really, really bright people.
Hmm.
If it could be done, they would have had some breakthroughs on specific problems. I think it's a principled failure. And I think that you can't boot up consciousness from unconscious ingredients. I think it's that simple.
That makes
You
sense.
cannot, I'll be very clear, a scientific theory cannot start with unconscious ingredients of any kind and boot up consciousness. It's just not possible. That's my hypothesis. I think
Wow.
if you want consciousness, you're going to have to start with an assumption.
There you
Uh,
go. Full
now,
circle.
and that's where I'm headed. Is my brilliant colleagues assume space and time. They assume physical objects and neurons in space and time, and then they also have to stipulate the conscious experiences, or stipulate that they're illusions.
Hmm.
What I say is, well, if I only stipulate the conscious experiences, and I don't stipulate space and time and physical objects and neurons, and I can actually start with my theory of consciousness and boot up space and time and neurons, then I've actually stipulated less. And so by Occam's razor, that scientific theory wins. So
Hmm.
the scientific theory that assumes only stipulate consciousness and then shows how space and time arises from it beats a theory that stipulates space and time and neurons and physical stuff and also is forced to stipulate consciousness. You're right, because they can't boot it up. So
Sure.
I think that ultimately Occam's razor is going to force us out of our physicalism and force us to take the idea that consciousness is fundamental quite seriously, simply because
Well said.
it will give us a smaller set of premises for our theories.
Well said. So I know we're running a little short on time,
Yeah,
but I want to ask you two questions. I'll ask the I guess the more difficult of them first.
sure.
Uh, has has anybody kind of refuted or criticized what you've said? And if they have, what has been, I guess you'd say, the most intellectual criticism that you've met in your theories?
Uh, well, yeah, I get. Of course, what I'm saying is so counterintuitive and strikes so deep at our sense of self
Hmm.
that I'm not surprised that many people react both positively and negatively. And so
Hmm.
I'll get emails from people
Wow.
saying that I'm completely insane,
Oh, wow.
or oh, absolutely, and then others say that love it. But the most the and there's all sorts of grades. But in terms of people who've really thought deeply about things, I would say that most of my colleagues who are studying consciousness,
Hmm.
and many of them are good friends of mine because this is my field.
Of course.
Um, they're happy to see me at conferences, and we chat and have a good time and so forth. But I think that most of them are still physicalists,
Hmm.
and most of them, they're cognitive neuroscientists or artificial intelligence researchers. They don't really know what's happened in the high energy theoretical physics community, that space-time is doomed. They don't
Okay.
know that the rug has been pulled on
Hmm.
space-time, and also reductionism
Reductionism.
is dead. They don't know it's dead, but it's dead
Hmm.
scientifically. So they're still thinking that we're going to look for the neural correlates of consciousness. What neural patterns of activity are correlated with my experience of the color green,
Hmm.
the smell of garlic, and so forth. Get all those correlations, and then we'll eventually suss out how the neural activity causes those conscious experiences. So
Mm-hmm.
most of my colleagues are still in that game. I would say 95, 99% of my colleagues. So of course they think that I'm dead wrong.
You're cutting
And
edge.
right, I'm on the fringe in that
Mm-hmm.
sense.
I like that.
But historically, in 1905, when Einstein published his special theory of relativity, Newtonian spacetime was dead
Mm-hmm.
as a fundamental theory. It's still
Right.
alive, of course. It's very useful for sending rockets to the moon and so forth. But as a foundational concept for science, no more.
Limits me.
That was over.
Mm-hmm.
But in 1922, when Einstein got his Nobel Prize, the
Mm-hmm.
Nobel Committee made special pains to say this is not for relativity theory. This is for his photoelectric effect.
Mm-hmm.
So they did not believe it was over for space-time. I'm sorry, it was over for Newtonian
Newtonian
space.
said, yeah.
Space-time was here and it was going to take over. But
Mm-hmm.
even the Nobel Committee, 17 years later, and these are careful, reasoned people.
Right.
17 years after it was over for Newton, the committee didn't recognize it was over.
Wow.
It's over for neural reductionism because it's over for reductionism.
Mm-hmm.
But even really brilliant people, this is so deep, it'll take decades.
Yeah.
But it's already over, but it will take a few decades for even the intelligentsia in my field to really grasp it's over.
Mm.
And we need we cannot reduce consciousness to anything inside space-time, including integrated information or neural activity.
Well, I'll ask you last question. You don't have to get too crazy into it. I know you're getting short on time, but do you believe there's an afterlife?
Um, yes, uh, I think that space-time is just a headset.
Mm-hmm.
And by the way, okay, yeah, I should be careful when I say, here's what my science is saying. Here's what I personally think, going beyond my science and so forth. So this is my statement here is part of both, right? I think part of it is based on what my science is saying, and part of it is my leaps based on what the science is saying. Space-time is just a headset.
Mm-hmm.
That part I think is pretty secure.
Yeah.
Death, then maybe just simply taking off that headset.
Mm-hmm.
That's less secure, but that wouldn't even be possible in a physicalist framework, right? That
Right.
idea is not even possible in physics, but it's certainly possible in the framework that I'm looking at. And the mathematics that I'm working on right now, um, where the very notion of time itself is with an arrow of time,
Mm-hmm.
is entirely an artifact of the projection into our space-time headset. That also lends credence to my belief. Um, I'm talking about my own credence, not
Yeah.
general, but my own credence in the idea that space-time and the feeling of life and death is just the life and death of an avatar, but the avatar is not me.
Mm-hmm.
So what's clear from this is my body is not me.
Right.
The body is just an avatar.
Right.
And now it's still possible that the death of the avatar somehow is the death of me ultimately,
Mm-hmm.
but is no longer forced. Whereas in physicalism, it's forced, right?
Right.
Death of your body is the death of you. In this other framework, it's not forced. So and if I had to bet, it would be 99-1 that there is survival
Solid odds.
after. But we're just at the beginning of the science outside of space time that could really nail this down.
You're right.
So I'm pretty excited about it.
That's amazing. There's a lot to unpack with a lot of what you're saying. I wish we had more time, but thank you so much for talking to me tonight. You're definitely a remarkable human being. I hope to, talk to you again someday, and definitely on the lookout for anything else you publish. So like I said before, I'll put your book up so people can find it. I know you
Okay.
have a website. You
Yes,
seem like you're fairly active on Twitter, X.
on Twitter. That's right.
Yeah.
Yeah. Yeah.
Whatever we're calling it nowadays, right? So, but thank you again so much, Don, for coming on. It was a pleasure talking to you.
Thank you, Brent, and wonderful questions. Thank you very much.
What's going on, Fire fans? I Came with Fire podcast is sponsored by Red Clover Coffee and Sheep's Clothing LLC. Red Clover Coffee is a veteran-owned company with small batch roasted coffees, and they just happen to donate to some pretty awesome charities. Whether you're into specialty flavored coffees, single source coffees, or having a really cool coffee mug and some badass slaps, Red Clover has you covered. You can order ground, whole bean, or even coffee pods and get it all at 10% off your entire purchase using coupon code Came With Fire. Again, that's 10% off your entire purchase using our coupon code Came With Fire. I personally love their Blueberry Invasion and African Roast. That Blueberry Invasion hits the spot. Head over and get yourself some awesome coffee and support us by supporting our sponsor. I Came With Fire podcast is also sponsored by Sheep's Clothing LLC. Sheep's Clothing LLC is a unifying banner for all violent arts, disciplines, professions, and survivors of violent circumstances. Redefine violence. Both Zach and I being survivors of violent circumstances and LEOs in the military, we are especially excited to be able to offer you 10% off your entire purchase with coupon code FIRE10 at checkout. Whether you're looking for an awesome t-shirt, hats, slaps, flags, or MMA gear, they've got you covered. Me personally, I love my snapback with the leather patch surrounded by God's flannel. If you know, you know. That's coupon code FIRE10, FIRE10 at checkout for 10% off your entire purchase. Thank you all so much for supporting this podcast, and if you should feel compelled, treat yourself by supporting our sponsors as well. They truly make a difference for us. Now let's make a difference for them. See you on the next show.